Hello everyone. Today we will be covering Python basics. In the previous video, we basically got started in Python, saw how to use it in simple form. Now we are going to deep dive into some aspects of Python that, everyday coders use and that you could use if you plan to use Python in your future career. So here we have data types, which we're just doing a refresher. Just These are your common ones you would work with. So we have your strings, which deal with your text data. Your integers and your floats deal with your numbers. The only difference between the two is that your float is using decimal numbers. And then you have your Boolean data types of true or false. And yes, they are just simply true or false as the data type. So again, a string is a sequence of characters inside of quotes. So if you need to use text data in Python, you have to place it within quotes. And once you do that, it is considered a string, and then you can use it within your code. So here we have some examples. Some are in single quotes, some are in double quotes, some have one letter, some have 10 letters. It doesn't necessarily matter how many letters or characters or symbols you have inside of the quotes, it's still considered a string. Variables, which you can use to store data. So yes, you can store your strings and any of those other data types as variables. And here are some examples. So highlighted in the purple is your variable names. So language, num1, name, and greet. Those are the variables. Okay. On the other side in black, those are your data values. The equal sign is assigning language to Python in the very first example. So the equal sign can be used to refer to assigning. So it's saying language is assigned to Python. Num1 is assigned to 1, 2, 3, and so on. So whatever you store on the other side of the equal sign will be stored in the variable name. And then from that point on, you would just call the variable instead of having to type out that specific data value over and over again. All right, now let's look at some operators. So you have three different categories of operators: your arithmetic, your comparison, and your logical. You should be used to your arithmetic and your comparison, and they work exactly how they work in your regular math. So adding, subtracting, multiplying, and dividing in exponents, your less than, greater than, equal to, less than, equal to, and not equal to. For the equal to, I want to point out that the equal in this case has two equal signs. You needed to have two equal signs because if we go back, you see that for variables, it needs to use one equal sign to understand that you're assigning a value to a variable. That's where one equal sign is used. But if you are comparing two numbers or two conditions and you're trying to say, is this equal to this, then you have to use two equal signs. It will not work if you use one. So you can't say 3 equals 5. You would have to say 3 equals 5 for it to work. And then if you're saying it's not equal, you would just use your exclamation point with the equal sign. Now, there is a logical operator, and this is typically used when you're trying to make decisions, which we are going to cover. But this is like if you're checking multiple conditions or checking multiple things within your code. So, for example, you have and, or not. Those are your three logical operators. So, and will do whatever your code is saying based on if your conditions or both of the conditions you give are true. So for example, you could have 1 is equal to 1 and 1 is less than 10. Technically 1 is equal to 1 and 1 is less than 10. So in that case, whatever code you have written under there would run. However, if you were to use an or, let's say you have 1 is equal to 5 and 1 is less than 10. Well, you know 1 is not equal to 5, but 1 is less than 10. So because 1 is less than 10, again, your code would run regardless. So in that case, just one condition has to be true to run, not both like and. And then you have not, which is basically saying if for example, num is not equal to 1, then do this. Or if 1 is less than 5 and you say not, it will be the opposite. So 1 is less than 5, so that is true. But if you say not, it's basically going to say the opposite. So obviously, that one's a little bit tricky. For the most part, a lot of times, many people just use and or, not necessarily the not. But it is just an operator out there that I wanted to share. All right, so moving from your operators, this is where it all makes sense now. This is where you combine your variables and your operators, or your values. So you're basically making an expression, and an expression is kind of like, what you do in math, a math expression. So in these examples, you could write these 2 lines of code. Total equals price times the quantity. Whatever the price value is stored in your code as a variable. So you could say price is equal to $1. And then you could say quantity is equal to 3. So what will happen is when your code runs, it will say we're going to make a variable called total that's going to equal the price times the quantity. And in this case, you said 1 and 3. So that will be 3. Same with the income. So this is just used to make your normal math expressions inside of your code. So combining those 3 things, your variables, data types, and operators, are very common for you to do basic coding and programming tasks. Now, in those cases, you may want to use some user input to store or collect data that you want to use. In all cases, you don't have to necessarily use input in every program, but if you're trying to make it interactive or use it for different use cases, your input will be important. So we have covered this, but just to refresh, you use the input function. Again, any value that is entered into the input function will be entered as a string. So if you are collecting number values, you would have to convert it to an integer using the int conversion. So that would be wrapping int or wrapping input around int, and then that will convert it. So again, it will make sense in examples, but we did cover this in the previous lecture, so this is more so just a reminder. All right, getting into some new things. We are now going to be talking about how you can make decisions inside of your programs. So before, there was really no decision making or options that you could do in your program code. It was more so just enter some information and print it out. But now this is where it gets a little bit more fancy, I guess you could say. So you have an if-else statement, which allows you to make decisions in your program. So it's basically saying you'll do this or you'll do this. So the first statement is the if statement. And the code will run under the if statement only if that condition on the statement is true. So, right now this may not make sense, but we will cover an example. So basically in this case, whichever condition is true will run. If the if condition is not true, it will not run, and it would run your else statement. So your else is like a default. If all fails, run this. So it would look something like this. For example, a condition could be if 1 is less than 5. In that case, 1 is less than 5. So whatever is under your if statement would run. However, if you say if 1 is greater than 10, that's not true. Your else statement will run because 1 is not greater than 10. So the condition is going to dictate which area of your code is going to run, and it's going to make a decision based off of that one condition. So do you have to use the else statement? No, but it's just a useful backup or a default in case your code does not run. It's just giving you something that will run to let you know, like, hey, your condition wasn't true, but the code still ran, and there's at least nothing wrong with that portion of your code. All right. Then you have a if, elif, else statement. So that is used to let you choose from multiple paths. In the last example, you only had one condition, one path. So if it didn't equal that path, it went to the other path, which is the default path. So that default path did not necessarily give you a condition. It just said, okay, if the first one failed, then just do this by default. But if you wanted to check through various things, then you can use a if, elif, else statement. So what happens with this statement is it will run through your code and check the various conditions you have. However, whichever condition is true first is what runs, and then everything else gets ignored. Even if you have 10 true conditions, whatever the first true condition is going to run, and then everything else basically becomes invisible. So this would look like this. So you see we have an if, condition 1, elif, condition 2, or the else. Now remember, your else is just your default, meaning if none of the conditions are true, your else is going to run. The one thing I would like to note in this case is that when you use a if, elif, else statement, you only have one if and one else. But you can have as many elifs as you want between the if and the else statement. So in this example, we're only checking 2 conditions, but we could technically check 4, 5, 50, 20. Would you want to? No, but you could, and that's the point of that part of the example. But you could technically say if condition 1, elif condition 2, elif condition 3, elif condition 4, and then if none of those are true, else. And then basically it's going to run whichever condition is true. Again, as soon as it finds a true condition, it will run whatever code is there and it will ignore everything else. Meaning, even if there is a true condition under that line of code, it's still not going to run it. So just keep that in mind. So here's some examples of some quick code screenshots. In the top left, this is just your simple if-else statement. And this is an example of if you were to enter in a number and need to convert it. So if you look on that first line of code in the first image, we have age equals int, which is wrapping the input function, and that's basically converting it into a number. So if you are using a condition and checking it within your if statement as a number, your variable has to be converted with any input. So in this case, you're inputting, telling your user to enter your age. And if they enter their age, remember, it's going to come in as a string. So in this example, the int converts it back to a number, so it can be used in your if statement. So now, in the if statement, it's saying if age is if age is greater than or equal to 18, then you're going to print that you're adult. So again, do you have to use else? No. So for example, if a user was to not include the else statement, what would happen is, let's say that the user enters that they're 10. So it would basically take 10 and then it would check it in the condition. If 10 is greater than or equal to 18, print you're an adult. We know 10 is not greater than or equal to 18, so nothing would happen if that else statement was not there. But because it is there, it would print out you're a minor. So any number over or equal to 18 would print you're an adult. Any number that is under 18 is going to print you're a minor. Now, that was a if-else statement. If you look at the bottom image, you see it is a if-elif else statement, and there are 2 elif options. So overall, there are 3 conditions that are being checked in this program. And then you have your else, which is the default, basically saying if, the score does not equal any of the conditions above, then we'll print this out. So again, let's say your user enters in 45, it would continue to check 45 on all conditions. So if 45 is greater than or equal to 90, which is not true, so it would skip that if statement. Elif 45 is greater than or equal to 80, that's not true, so it would skip that. Elif 45 is greater than or equal to 70, again, that is not true, so it will skip that. So the only thing it can do is run the else statement. So it basically would print to the user that you need improvement. And if you have a 45, you definitely need improvement. However, if we were to say that, the score is a 82, for example. So it would take 82 and say if 82 is greater than or equal to 90, then the grade is an A. That's not true, so skip that. Elif 82 is greater than or equal to 20. That is technically true. So therefore, your if statement will stop right here and it will print grade B. That means the next condition, which is the score is greater than or equal to 70, gets ignored, as well as that else statement. So the only thing that would run if you enter 82 in this case will be grade B. So that is how you use these to make decisions. It's basically going to check if this is true, then run this. That's the whole point of this. All right, getting into another new topic, list. So there may be times where you want to collect a lot of data, which, for example, if you had various items, or if you were making a cash register, or if you were making guess the word or guess the name, you would want to use a list. Because a list is a collection of items within a bracket is what we call them. So you have a left and a right bracket, which you see there. And you can have as many things inside of a list as you want. It's a limited number. So the items inside of your list are separated by commas, but they can hold any type of data types. So if you look in the example, we have names, we have numbers, and we have random. All of those are technically lists. How do we know that? Because they have on the other side of the equal sign various items, but they are all enclosed in brackets. So the first one is saying that we have a list of names: TJ, Ashley, and Mike. Again, you can have as many as you want. You can even have one name in there. Doesn't really matter. Once the brackets are there, it tells your code that it is a list and it's going to treat it as such. Same with your numbers. We have various numbers in there. And random is an example of a list where you do not necessarily have to keep the data type the same in the list. You can have multiple data types inside of lists. So in this case, it has all data types. It has strings, it has integers, it has floats. So it doesn't matter overall what the contents is as long as it has brackets around it. So a list can be very useful when you're trying to store or do various things, which I will show you in a second. All right, functions. Functions is a very useful thing inside of Python. It basically allows you to perform a specific task, but it combines various lines of code together for you to run them, which again, it will make sense in the example. But in this case, we could say that your functions are used to help you organize code, and it basically helps you avoid repetition. So if there's some sort of lines of code that you need to run over and over again, this is where it will come in handy. So here we have an example of how a function is set up. And if you pay attention to the colors, if you look at the bottom half of the screen, it will explain what each component is. So that's what we'll cover right now. So DEF or def, it's basically say defining. So you're defining a function name, and that's what's going on here. So when you say DEF, it's telling Python, hey, I'm creating a function, and then it knows whatever comes after that is the function name and the input into that function. So the function name could be whatever you want, very much similar to a variable, as long as it does not start with a number. So you can name, for example, this function name, def name, and then you have your parentheses. You have to always have parentheses within the first line of your function when you're creating it. You do not necessarily have to put anything in it. So you do not necessarily have to have parameters. And parameters are basically input. So for example, if you have user input and you want to use it in your function, you would place it into the parameter section that is highlighted in red. But again, you don't have to put any input into here if you do not want to. So basically, you're saying that on the first line, you want to create a function, and whatever that function is basically going to run the code under it. So kind of similar to your if-else statements, except it's just a function and it's not checking a condition. Return is there as well, but is optional. You do not have to include that, but this is typically used if the function deals with numbers. So again, this might not make sense right now, but it will once I go through an example of it. So here are two examples. You simply have a function at the top that is saying that you're creating a function named greet, and greet is taking the input of the name. And again, name is a variable that you would have created above. So it's basically saying anytime you run that function, you want to input whatever the variable data is for a name and then use it inside of the function to print it out. That's what happens in that case. But an example of how it would work if you were to enter the parameters is on the second image. If you see there, we have a function called add, and it's saying we're taking an A and B. A and B basically mean placeholder values for two different things. In this case, if it's saying add, we're going to assume that it's going to be two numbers of some sort. Now, it's not basically saying that it's two numbers, so technically a person could put in two strings, but it will cause a problem. So basically in this case, it's just assuming by numbers and the name of the function that you will be adding two numbers. So if you look at total, it says total equals add 3, 5. If you look at where the definition of the function is, def add A, B, it basically matches that. So the two are the same. So that is where it's calling your function. It's saying total is going to store whatever the return result of 3 plus 5 is, and then it will print it out. So that's the case of a function. And these are simple cases, but I will show you some in a coding tutorial. All right, so wrapping up our last topic, we have loops. So loops are exactly what it sounds like. You want to run something over and over again without having to rewrite it. So this can be used to print your list contents. It can be used to collect various inputs. So if you're trying to collect a lot of input from a user, it can be used to run calculations. But regardless of that, it's going to run for a certain amount of time or a specified amount of time until it reaches a satisfaction condition. So there are two types of loops, for and while, which we'll cover. So your for loop is used to loop over items, and your while loop will loop until a condition changes. So typically your while loop is used like an if statement. It's going to do something until your condition is false. Whereas for your for loop, it's going to run for a specified number of times. So if you know how many times you want to run the loop, or if you know how many items you need to check, you would use a for loop. So this is typically used if you're trying to check the items or use the items within a list or a string or a range of numbers. Your while loop is more so checking a condition. So example, while number is less than 10, we want to do this. And as soon as that number is greater than 10, it will stop running. So let's look at some examples of that. So this is how you would write it. So again, your while loop is more so set up like your if statement, except it's just saying while instead of if. And while that condition is true, you're going to run whatever code is under it. Whereas for your for loop, it's going to say for item in sequence. So for item in this list, for letter in this string. It's just some examples, but it will just check through a range of numbers or a specific string, a specific list, for example. So here are two examples. For your for loop, we have a list called fruits, and it has 3 different fruits in it: apple, banana, and cherry. So in the for loop condition, it's saying for fruit in fruits. So basically, for every fruit in fruits, you want to print the fruit. That's all this is saying. So basically, one by one, it will go through the list and check each item in the list and print it out. So say apple, banana, and cherry, and it will print them all out to the user. If we look at your while loop, you see it has a variable called count, and count is used in your while loop. So it's basically saying here, while count is less than 3, you want to print whatever that number is. And then that last line of code where it says count plus equals 1, it's basically saying you want to add 1 to count. So if you were to run this code, basically when it first starts, it would say while 0 is less than 3, then you want to print counting, and it would print out 0. Then it would add 1 to 0. So now count will be 1. So again, it does it again. While 1 is less than 3, we want to print counting 1, add 1 to 1, that will be 2. It starts again. While 2 is less than 3, we're going to print counting, and we're going to print 2, and we're going to add 3. Then we're going to go back to the top of the loop. Now we're at 3. So if you say it again, while 3 is less than 3. Is 3 less than 3? No, it's not. They're equal. In this case, we did not use the less than or equal to, so therefore the loop would stop running and nothing else would print out. If you did the equal sign, then it would have printed out that last 3, but in this case we did not. So basically your loop in the while loop will run until your condition is false. So as soon as we hit 3, it stopped running. So overall, what did we cover today? We covered our data types: strings, variables, operators, expressions, user input, lists, functions, and loops. Now these are all your common things that you need to know if you wanted to get into Python. Again, we're not deep diving into Python. That is a whole nother area and a whole nother semester worth of information, but we're just covering some basic things and some cool things that I wanted to introduce you to in case you want to get into programming or are interested. So what we covered are the common things you need to get started in writing a Python program. So I will show in a coding tutorial how to use all of the information we covered, and hopefully you see use in it. Of course, some people may say I don't have any interest in using it, which is fine, but just remember that this is used to run some software's apps that you use every day. So to see how your apps are actually programmed or set up to run is cool. So we will go through the various examples of the things we covered in here. Hopefully it will make more sense then. So I'll see you in the next video.